Okay, so for problem 2, this is actually a little bit faster because it's already factored for you. And so your first thing that you're gonna do is, just like on this problem, you're gonna find these numbers that make your value 0. And just like here, we factored it, we found that was -2. Here we set that equal to 0, we found that number. So here, it's actually quite easy. This one is the solution x equals 0, because if that was 0, this would be 0 times -1 squared times -3. Well, 0 times anything gives us that 0. The solution for this one is x equals 1. And if you can't do that in your head, you can always take these things and go off to the side and say, when is x minus 1 equal to 0? I'll add 1, and we get x equals 1. But it's pretty obvious that 1 minus a 1 is going to give us that 0. Now think in your head right now, what number minus 3 gives you 0? Well, again, you could come off to the side, and whatever that is, you can set it to 0, or you can simply see that that's an x equals 3. So we're going to go ahead and put these on our number line from -infinity to infinity. And then you're going to have a 0, a 1, and a 3. Now, these are gonna be x's. And the reason why is because this symbol says just less than 0. And for that, we know that these numbers all make the equation equal to 0. And since that symbol is not there, these are not part of the solution. Okay, now, unlike the last problem that said greater than, where we were looking for the solution being the plus, this is the less than symbol, so we're looking for the minus. All right, so we're gonna just go ahead and plug this right in. Let's pick a number less than that. We'll go -1. Here we'll pick 1/2. Here we'll pick 2. Here we'll pick 4. Why not? All right, so plugging in -1, this is not an enjoyable task, but I love you and I'm gonna do it for you. So plugging in x here, you're gonna have a -1. And then here I'm gonna have -1, -1 is a -2, and you're squaring that, so that's gonna give you a 4. Now take that -1, plug it in here, and you get -1 minus 3 is a -4. And a negative times a positive times a negative is gonna give me a positive. Now, actually here, you really do need to do all 4, and this is fancy math, but this actually here is the reason why it's gonna bounce, and you might have a repeat of being up or down. So we do have to do this, unfortunately. Okay, so here we're gonna have a 1/2. Here, 1/2 minus 1 is a -1/2.
Squared.
Oh yeah, and squared, it's gonna be positive. Thank you to my special cameraman. So, so this is gonna be I'm plugging in 1/2. So 1/2 minus 1 is a -1/2, and then squaring it becomes a positive. Honestly, I don't care that it's a 1/4, I care that it's positive. And then plugging a 1/2 into this gives me a -2.5, which I'm just gonna write as a negative. So, and here I probably would have just written positive. So I've got a positive times a negative gives me a negative. All right, now plugging in 2. Let's do it fast. That becomes a positive because that's gonna be 2. 2 minus 1 is 1. 1 squared is 1, so that's gonna be a positive. Now taking 2 and plugging in here, 2 minus 3 is a -1. So here's the surprise where you actually do get a repeat in a row, because that one was a positive, that's a negative, and that's a negative. Okay, now plugging in 4, I'm gonna get a positive because I get 3 squared is 9. Sorry, it's a lot of animals meowing. And then 4 minus 3 is 1. So we get a positive times a positive times a positive. So there's our cats are fighting. Oh my goodness. Guys, no fighting. Okay, so now remember, we're looking for less than. So our solutions actually come from this, and we cannot have the number 1, and we cannot have 0. So our solution is in the middle of this and the middle of that. So I'm gonna have my solution be 0, 1, union 1, 3. And you might say, Sword Dog, why couldn't we just say from 0 to 3? Well, we can't have 1 And that's why I had to have that open bracket symbol saying that I can't have 1. So this is saying I can't have 0, I can't have 1, I can't have 1, I can't have 3, but I can have everything in between. So there's that. Now, personally, I actually would have done this problem differently. I would have said, and you can ignore what I'm about to say because your professor probably didn't teach this, but this is, I noticed this is x to the first, x squared, and then this is to the first. So this is a 4th degree polynomial, which I know that end behavior is up, up, because these are all positive, positive, positive. And I also know my roots are 0, 1, and 3. So this graph actually looks like there's a 0, there's a 1, and there's a 3. And I know there's a bounce on the 1 because that's an even. So this is a bounce. So I know it starts up, it comes down, and then it bounces off the 1, comes down, and goes like that. And so this question was asking, when is your graph less than 0? Well, it's all the places it's below the x-axis, but it's not at the 0, not at the 1, and not at the 3, because those are the 3 numbers that make it equal to 0, and that does not have the equal. If you have no idea what I said here, completely ignore that. I was just trying to impress David.
It worked.
But I would probably just go with this kind of number line method. All right, that's problem 2.